In Module 5, we learn about discrete probability distributions. And in this module, we will learn about continuous probability distributions. In Module 5, for example, if we roll a fair dice, and the outcome, x, could be any number between 1 and 6, any integer number between 1 and 6. And the probability of getting each outcome is 1/6 all the way through. Notice that when I sum up all of the probabilities, we have the total probability equals 1. And that is always true if we have a probability distribution table. And that is for discrete random variable. Notice in discrete random variable, the probability of getting a particular value is defined in the table. And for a value that is not defined in the table, for example, a probability of x equals 1.5 should be 0, because x is only defined at those 6 possible values. Continuous probability distribution is very different. We could have a value between, for example, anywhere between 1 and 6. It doesn't have to be 1, it doesn't always have to be 6. I'm just giving you an example. It could be x could be well defined anywhere between 1 and 6. And notice that the length of this rectangle is 5. So let me write that down. The length of this rectangle equals 5. If I let the width or the height of this rectangle equals 1/5, then the total area, let me use red. The total area would equal to length times width, which is also 1. And if we let this 1 equal to the total probability, then we have what we call the uniform probability distribution. So this distribution is what we call the uniform distribution. Notice the width or the height of this rectangle remain the same. And also, for continuous random variable, we won't talk about the probability of x equals a particular value. Instead, we will say the area around a particular value equals 1, and using that, we will define the probability. So when you go through the homework, you will understand what I'm talking about at this moment. Another thing I'd like to point out is, for discrete random variable, in general, we know that the probability of x greater than or equal to 2 does not equal to probability of x strictly greater than this particular value. But for continuous random variable, the probability of x greater than or equal to a particular value, let's say 3, always equal to the probability of x strictly greater than the same value. And that is because for continuous random variable, we use an area to describe the probability. Just think about a piece of land. With or without a fence, the total area of that piece of land remains the same. And if you imagine that equal sign as the fence, then with or without that equal sign, the probability remains the same for continuous random variable. So that was uniform distribution. A distribution we use far more often than uniform distribution is what we call the normal distribution. And the probability density curve have this bell shape. And notice that for normal probability distribution, this curve is symmetrical with respect to the mean. And also, a particular event occurs near the mean is far more likely to happen than an event occur far away from the mean. So that is what you're going to learn about normal. Let me write that down. Normal distribution. And we are going to cover 3 sections in Module 6. First, I will introduce continuous probability distribution with uniform distribution. And then we will move on to standard normal distribution, which means the mean equals 0 and the standard deviation equals 1. In 6.3, we are going to generalize the normal distribution to non-standard normal distribution. So as you go through the module, those are the things you need to pay attention to. And this is the end of my orientation video. Thank you very much for watching this video.